Chapter 4 review. Okay, so today we're going to do antiderivatives and integrals. And we'll do an example of an antiderivative. It is going the opposite way of a derivative, so you'd work backwards. Because when you take the normal derivative, you subtract 1 from the power and multiply that down. When you go backwards, you would have to add 1 to the power and divide it by 2. So you get x squared, you get the derivative of that is 2x, and the antiderivative of that would just be x squared. So this is called an integral, and you'd read this as going the integral from 0 to 5 of 2x with respect to x, because that is the variable that you're looking at. These have to match. And so what this is meaning is the area underneath the curve of the line. So that would be, and this is a triangle, so it would be easy just to go 5 times the height of 10, 5 times 10, and then you divide by 2 because it's a triangle, which is 2, and you get 25.
So the next topic in chapter 4 is called area Riemann sums, and you use this to estimate, but it's not an exact value, but you use intervals. So if it's the integral from 0 to 3 of x squared, you're trying to find the area under the curve. If you use right Riemann sum, then you take the farmost right point, so you start at 3, so the value at 3 is 9, and so you draw basically a box that goes to 2, and then you multiply by the width of the box to get the area, and this one will be an overestimate because the box hangs over. And then for left, you start with 0, and so you start from 0, draw a box, it's obviously going to be 0 because there's nothing in there, and then you go 1, and then the value at 2 and draw it over, but you're not going to use 3 because it's not going to hang over like this one. And for the midpoint one, you just take the value that's in between the two intervals.
Alright, we have a special guest to help us explain U substitution, Dylan Rose. Alright, if you have a function such as this and you're trying to integrate it, and you don't know how to integrate this, you can use U substitution to make it a simpler problem. You can see that the number on top is the derivative of the number on bottom, and you can set the number on bottom to u, which equals x squared. And du, which is the derivative of u, is 2x. So now you have the integral of du over u, which you can simplify to the integral of 1 over u times du, which is ln u plus c. And then you plug in what you had for u into the integral, and you get ln of the absolute value of x squared plus c.
Okay, today we're learning about the fundamental theorem of calculus, which is abbreviated FTC, and it's one of the most important things you need to know for the test. And it says that if you have an integral from a to b of some function with respect to x, then it's going to be the integral of that function while plugging in b minus the integral of that function while plugging in a, and that'll give you your answer.
Trigonometric integration. As you can recall, the derivative of sine theta is cosine theta, so the integral of cosine theta must be sine theta, but remember to put plus c. As with the derivative of cosine theta, it is negative sine theta, so when you integrate sine theta, you must put in a negative sign and then add plus c.